Welcome to Accelerated Chemistry. Why does anything exist at all? And why and how do things stably exist? This investigation into the very nature of things themselves first begins with us separating certain things from other things. We first encounter, at least in the majority of things, things made of two or more different things, mixed together, what we call mixed substances, or simply mixtures. The most evident type of mixture is one made of phases that naturally separate from each other. The gravitational force simply pulls down the heavier particles, drawing them to and settling them upon the ground. These mixtures can easily be separated by using a filter, which allows only sufficiently smaller particles to pass through tiny microscopic holes. Suspensions are considered for this reason heterogeneous, existing of two or more different phases. Colloids, however, are homogeneous mixtures. That is, they do not settle out due to gravity, but have two different phases that are attracted to one another. Of these, we can distinguish a number of kinds. Our first set features either liquids dissolved in gases, called liquid aerosols, or solids dissolved in gases, called solid aerosols. The examples of liquid aerosols that you are probably most familiar with are fogs, clouds, or mists, in which liquid water is dissolved in gaseous air. For examples of solid aerosols, we can have smoke, in which solid particles of carbon or other combustible matter may be dissolved in the air, or even thunderclouds, in which solid water particles are dissolved in gaseous air. Our next set features either gases, liquids, or solids dissolved in a liquid medium. Foams, like whipped cream, dissolve air into fatty liquid milk. Emulsions, like cream or milk itself, are made of liquid fatty acids dissolved in liquid water. And sols, like paint, can have solid polymers dissolved in various chemical solvents. Finally, we can have solid foams, solid emulsions, and solid sols. In cake or bread, pockets of carbon dioxide and air can become trapped within the solid phase. In cheese or butter, liquid fatty acids can be trapped in the more solid fatty acids and solid proteins in the case of cheese. Finally, in gemstones or metallic alloys, a variety of solid phases can be mixed with one another. Of course, this list of examples is not definitive, but exemplifies how diverse the majority of substances are that you have already encountered on a regular, daily basis. We end our short discussion of mixtures by referring to solutions. Solutions, though comprised of a solute dissolved and a solvent dissolving, exist as one complete phase. Their attractions are so complete to one another that one must completely overcome these intermolecular attractions in order to separate the substances from one another. Note that the solutions that exhibit color below are more rare compared to those that are both translucent and colorless, like salt water. From this, we end upon a note of investigation. If the force of gravity was dominant in heterogeneous mixtures, what force is then dominant in homogeneous mixtures? To put the question a slightly different way, would the dissolved salt in an unopened Gatorade bottle ever settle to the bottom of the container? The answer is no, for the attractions between the salt particles and the water are so strong that the individual ions are kept surrounded by water in the solution. But then, what is the source of this attraction? The essential takeaways of this video are as follows. Suspensions are heterogeneous mixtures because their phases naturally separate from each other due to the force of gravity. They are opaque, not allowing light to enter completely through, and their particles are significantly larger in relation to other mixtures. Colloids, however, are of smaller particle size and do not settle out due to the force of gravity. However, they are also still generally opaque. But solutions have the smallest particle size and are distinctly translucent, allowing light to completely pass through the mixture. Till next time when we consider the mysteries of the absolute, Crip.